It's the 1960s, and physicists kept running into a problem with something called the Standard Model of particle physics. It kept theorizing that force-carrying particles have no mass, yet they did. And why was this? It's due to something called the Higgs field. But before we can get into the Higgs field, what even is a field? Well, there's something called quantum field theory, where there are fields everywhere. They exist everywhere in a universe. An excitation in this field is what we call a particle. Fields also have a certain amount of energy associated with them. And the lowest point in that energy is called our minimum energy state, or vacuum state, which is its preferred state. Like how you and I, when we get tired, like to take a rest, you could think of it as a field doing that. Now, there's also something we like to call our zero particle state, which is like an empty box, where there is no particles in that field at the time. Now imagine I drop a ball in the universe. If I were to move somewhere else and drop that exact same ball in the exact same way, the result would be the same. So symmetry is our representation of our law of conservation. Now we can take a look at something called our Higgs potential. Now if you see, our zero particle state is above our two vacuum states, meaning our vacuum states will have particles in them. Now, if we were to add a ball into this example that represents our Higgs field, over time, that ball would roll into one of the two vacuum states, which would break the underlying symmetry, which is something that the Higgs field does. Now, if we were to imagine a particle, per se, or force-carrying particles, interacting with this field, it's like dropping a ball into water. That particle would experience pushback. So by interacting with all these particles in that field, it's going to cause it to slow down, which, even though it was moving at the speed of light before, now it isn't, which causes it to experience inertia. And once it experiences inertia, it gains mass, since the two are proportional. And that's the Higgs field explained.